Hey guys, I'm Simon. Thanks for coming tonight. I've just got one request, and that is this is my first time as a speaker, so please be gentle with me. So we've been using AR for about a year, and everyone's going to go, hang on, ARKit hasn't been out for a year, but there are other libraries. So we started playing with one called Wikitude about 12 months ago. It had a slightly different kind of bent and skill sets. It was more about for marketing, so it specialised in image recognition. Hold your phone up, see something, then it'd augment some overlays like some advertising or something around the image, and was also good for geo-positioning of content as you looked around the world as well. So interesting to look at ARKit, been playing with that since June, and the different sort of mentality that you need to bring to the table there. Show of hands, who has worked with ARKit? Who's opened it up, done the sample? I'm guessing a lot of people would have done the samples, Googled a bit, done a bit of playing. Has anyone taken something through to production quality? I know the Redbubble guys have seen your awesome work, that's awesome. Me, I'm still searching for the commercial reality of where to play. We're currently using it for some bait and some teas and around some other things we're doing. Come and have a chat to me afterwards if you're actually doing anything, because yeah, we can swap stories. What we're going to do tonight is I was going to start with jumping into doing SpriteKit texture rendering onto ARKit geometries. That was an idea that was picked up from one of the WWDC presentations. I think it was 609, called Going Beyond 2D with SpriteKit and ARKit. And they showed how you could take a SpriteKit texture and render it. So I saw that and thought, well, actually that looks pretty cool. I'll do that. But they didn't give away many details. So in exploring that, I sort of found about what it means to bring it in, what it means to sort of try and do user interaction between ARKit and a SpriteKit texture, and come up with some tips and traps around how that works. But to actually get there, what we're going to do is we are going to build a ARKit solution. So we are going to do live debugging of Xcode in front of a crowd. So what could possibly go wrong? So we're going to go through the basics around just creating a ARKit session and what it means to create and place a basic geometry there. We are not going to be building the IKEA app. This is not going to be sexy. This is going to be purely hello world. Just follow the bouncing ball around what it means to get something basic up and running. Right, so steps to do it. We're going to use the SceneKit version of ARKit. We're going to create a basic SceneKit node, create a very basic out-of-the-box geometry, and then position it into the world. Basically 3 techniques for positioning something into the world. You can either float it at a fixed position, you can do manual world geometry detection where you say, I want to put it there and tap the screen and have it put something there, or you can let ARKit go and automatically detect the planes and put things around the world for you. We'll start by doing the first one. The first one is just basically using the SceneKit approach to positioning objects. I get a node with the geometry and I say I want to put it at X, Y, Z over there and let it happen. In the other techniques, we're going to use the more ARKit friendly way of doing things where it uses anchors. Anchors are ARKit's way of remembering where things are positioned in the world, and then you attach your geometry onto the anchors that it provides. The difference when using the anchors is that if your session gets interrupted, ARKit may decide to tear things down and then rebuild its view of the world. So anchors is the sort of recommended way of doing things, but you can do it either way. So Xcode, what we're going to do, what is that? That is a SpriteKit game I'm going to come back to later. That is the Hello World SpriteKit game. Damn you, PowerPoint. Yeah, I want to try and enable mirroring. I don't like this other view. All right, cool. All right, so new project. What we're going to do is we're going to go for the augmented reality app, AR demo. We're going to use the SceneKit variant because you're playing in a 3D world, you may as well use 3D shapes. And bang, away we go. So let's have a look at what we get out of the box when we do this. What it's going to give us is a view controller with, that is impossible to read, but that is and ARSCN view, which is out of the box there. If we have a look at the view controller that has come up with, do I need to zoom that a bit? Yep. Right. So we've got a view did load there, which sets up the delegate, because this view controller implements ARSCN view delegate and loads the scene. View will appear as when it actually starts to do the work with creating the AR session. First thing it does is it sets up one of these configurations. By default, they've gone for a world tracking configuration with 6 degrees of movement. You should actually call world tracking configuration.is supported to make sure that your device can support it. If not, you fall back to a orientation tracking configuration. If that's not supported, we probably shouldn't have brought the users into this view of the app to actually be here. And there's a flag you can put in your plist to stop people from downloading your app if it actually depends on ARKit. All right, so let's get down to work. Now that we've got ourselves a view there, let's have a look at the scene that it's loading. It said it was loading this thing called the ship scene. There it is, it's loading a ship. I don't really want a ship in my demo, so I'm going to can that out. We're going to create a manual geometry and add it in instead. All right, I'm also going to add in an asset to help me on the journey. There's a little CocoaHeads asset. Boom. Rather than bore you with typing, I've got a bunch of snippets to bring in instead. So the first thing we're going to do is just put in a little helper to create a geometry. So this is a little function, create a node. SCN nodes are what we work with. First thing I do is create a material. So I've got a material and I've assigned its texture to be the CocoaHeads logo. I've called it double-sided so we can flip it around. I then create a geometry. We're going to create a basic plane geometry of some size and width, and then set the material to be the first material that's used on the geometry. Depending on the geometry you choose, it may have many materials. I'm using a simple geometry. I'm just going to assign the material to the first one, and then I create a node based on that material. So this is all standard SceneKit behavior, which is what we're going to use to do ARKit with the SceneKit configuration. The next thing I'm going to do is create that node and add it into the world. What am I going to do? I'm going to start with making myself a geometry size so I know what I'm dealing with. My geometry size, I think I need to go for about, geometry size is going to be measured in meters. When we're actually dealing with textures and everything, that's going to be measured in points. So we just have to be mindful about the translation of between meters and points when we're dealing with this world. Right. Bang. So I've created a little function there called initMyScene. initMyScene is going to create that node that we referred to. It's going to position it in the world, and we're just going for a hard and fast positioning here with those 3 coordinates being X, Y, and Z. X being left to right in front of me, Y being up and down, and Z being back and forth in my space. So by saying my Z is minus 1.5, I'm positioning it 1.5 metres in front of me, and then I'm going to add the node that I created to whatever node I've been given. In my view will appear. I'm going to call, what could possibly go on? Scene view has a scene which has, spell scene right, we'll get further, which has a root node. Right. We should be right to roll. Let's blast that up and see what happens. My experience has been that it takes about 30 minutes to deploy to my phone over wireless. I'm not sure if it's my phone or what it is, but I'm not doing that. All right. Almost knocked my laptop off before. Do I have QuickTime Player? I do. That is a very disturbing sight. All right, cool. Let's launch this puppy and see what it does. Gee, a build failure here would be embarrassing. All right, I should get a request. Okay, so there we go. So basic ARKit. We have our little geometry there, being created in 3D space. If I risk moving my thing off, oh, there we go, we're on the other side of him. Cool. All right. So from there, that was the first technique with putting the geometry in the world. What I'll do next is well, that's pretty basic, that's just using the standard SceneKit approach. How do you do it using anchors and actually being able to look for spaces in the real world to attach that geometry to? So the way we do that is with hit testing. Now there's two versions of hit testing in ARKit. One is to say I want to hit test and I want to look for a world geometry, a world object. The other way is we do a hit test and we want to look for a ARKit geometry. So the first one we'll do is have a crack at hit testing for a real world object. What we want to do here is run a hit test. So a hit test is based on me pressing a point on the screen. I want to run a ray from my phone through to the world, and I want to find the first object in the world that hits. So the way we do that is with this scene view hit test here, and to say I want you to go and look for a real world object, and I want you to estimate a horizontal plane. That is going to have a quick and dirty look for a horizontal plane. It will be less accurate than the actual automatic plane detection, but it will give you a quicker result. Once I've got a potential hit, I want to then go and create an anchor in the world such that I can then attach node to it. So what I'm going to do is create myself an anchor and pass in the world transform. That world transform that it's found is a very complex 4-part, that's unreadable. It's basically a set of 4 vectors describing your origin, I think it's your origin, the rotation of the point, the Euler angles of the point, and the transform of the point, and a scale or something like that. So it's pretty complex, but we just pass that into the anchor, and the anchor will know what to do with that. Once I've done that with the anchor, SceneKit will kick in and say, a new anchor has been added to my world. I need to go and start the anchor life cycle. And the first thing it will do is we'll go and say, I need a node, and you can give it a node to associate with that anchor, and then it will start informing the delegate that a node has been added. If you want to do something with it, you can. So it will call into this delegate method for SceneKit here and say, I have added a node, do you want to do something with it? And at that point, we do. We're going to use that base node and associate the node or the geometry that we want to put into the world with what's been passed in. The recommendation is that you don't try and put a geometry on that. You don't try and make a geometry with that node itself. SceneKit will do things with it and transform with that node it's got with the anchor. You go and put your stuff on top of the node that it gives you. So at this point, I'm going to go and call my little initialization thing I did with just this one, with the node that's been given, to say, go and put my node on top of the one that's been found in the world. All right, so I don't need to automatically do that. I'm going to wait for my hit test to find the point. All right. The other thing I'm going to do is that now that I'm going to use the anchor to position, I'm not going to position that node myself. I'm going to let the anchor position it. But the anchor will position it at the center. So I've got to do a little bit of a hack. And actually, because the plane's going to be vertical with the center in the middle, the point might be on the ground. I don't want my plane going through the ground, so I'm just going to bob it up just a fraction to sit on top of the ground. All right. Let's see what that does. Right, depending on my lighting environment, I may be really helpful if I implemented touch to actually call that, wouldn't it? Tip for beginners. All right, I'm just going to use a basic touch to say, when I get the touch, go and run the hit test. touch, hit test. I'm just going to use a basic touch. I'm not going to bother setting up a gesture or anything, but works equally well with a gesture. Okay, let's try that again. Oh, there we are, got a couple there. So it's found an anchor point out there near those first chairs, that first row of chairs, and it's positioned it there. So the hit test has detected a point, created an anchor, passed that into added that to the ARKit session, and then the session has gone. The session has gone and added that to the world. Right. So that's the basics. That's the basics happening there. So from there, what I want to do is go through and just look at saying, now that we've got that going, how do we then bring SpriteKit in, where I was originally going to say, put SpriteKit in, and then let's get the SpriteKit scene and use that as the texture for that node I've just created. When we do that, so we're going to bring in a SpriteKit scene. We're just going to use the basic Hello World game that's from the Xcode SpriteKit template. A few differences when we bring it in. The SpriteKit scene we bring in, normally SpriteKit scene's owned and managed by an SK view. There is going to be no SK view in this world when we bring it in, so we're just going to have to change the way that the scene sets itself up so that it can do that without using the view. So there's going to be no did move to view, and the template puts a lot of initialization in did move to view, so we've got to move that. Often the scene size and frame set by the view itself, that's not going to be there, so we're going to have to manually set the scene frame size as well. And there's going to be differences in thread behaviour, but I'll come back and talk about that a bit later. So what I'm going to do is I had a SpriteKit game. So this is the SpriteKit Hello World template. Let's just confirm what this basic game does. Yes, it says Hello World. And it's got some touches to say, when I touch it and I move around, it's going to follow the touches moved and respond, and it's going to pulse that Hello World. So what we want to do is to get that texture rendering on the geometry in ARKit, and then be able to pass through the gestures from ARKit through to that SpriteKit so that that texture responds to touch input as I touch the texture in the ARKit. When we're using that, so some gotchas when using SpriteKit with ARKit in this way. Shape nodes don't work. Shape nodes will give you an instant crash. Enumerate child nodes will also give you intermittent crashing. Threading is a bit different. So in SpriteKit world, both your user input and your SpriteKit update loop both operate on the main thread. When you're running in ARKit, your gestures are still on the main thread, but the SpriteKit update loop is being controlled by ARKit, which is running on its own thread. If you're using user input gestures to modify the hierarchy of the SpriteKit node tree, specifically when using physics bodies, I've found that a problem. You'll get a condition where you're manipulating the node tree in one thread while SpriteKit's trying to do its processing of that node tree in another one, and you run into array enumeration exceptions. So the technique we had to use there to fix that was to say, when I get a user gesture, just cue that gesture over to the ARKit thread so that it can be properly processed on the ARKit thread, and there'll be no problems. So that's all. Thank you very much for listening. My name was Simon. I'm the practice manager for mobile web custom dev at Oakton. If anyone's doing anything cool with ARKit, I'd love to catch up for a chat afterwards. So thank you for your time.